All right, good afternoon, good morning, whatever the case may be. We are going to define a few terms and sharpen our algebra skills today. So we're going to be working on altitude and median, perpendicular bisector, and angle bisector. So let us start with altitude. Alright, so let's draw a few triangles. And one like this, and one that is like this, and one that is like that. Okay, so those are our three triangles. The altitude is how tall it is from any given side. So say we're looking at, AB in each one of these. The altitude would just be how tall it is from AB. And this one's a little bit tricky because we need to get a 90-degree angle here in order for it to be the true height. So you're going to have to extend this a little bit to get there. Okay, so the altitude is height of a triangle. And then it intersects opposite side at a intersects the opposite side at a 90-degree angle. So that's what an altitude looks like. Okay. So the next one is median. Okay, and a median, let's draw some examples, kind of the same triangles we have here. Let's draw them again. Okay, so the median goes from the vertex to the middle of the opposite side. So these are just approximations, but I'm going to say those two are the same. So then we'd be here. Okay, and we can also, same with altitude too, and maybe I didn't do a good enough job with altitude, but let's address it now. So it can start at any vertex. So I could go the median from here would go across to the middle of the other side. Okay, so that, say those two are the same. Okay, and same thing here. Let's say we are going from this one. So I'm going to find the middle of this side. I'm going to say it's right there. Then I'm just going to connect it. So then obviously, if this was 2, this would be 2. If this was x and this would 4, x would be 4. Obviously if this is 2x and this is 10, x is 5. Right? You can do all those kinds of things with that, because they're equal to each other. Right? If it splits it in half. Okay. So the median is a segment from the vertex to the midpoint of the opposite side. Alright? Oh, let's scroll that down there. Segment from the vertex to the midpoint of the opposite side. Let's bump that up so you get that in there, and then I'll put down the next note card, which is perpendicular bisector. Okay. So if we're talking about perpendicular bisectors, let's draw our triangles. So I guess let's think about it like this. So if we have a segment here, and we've got a perpendicular bisector, so that means that it's going to cut it in half, and it's going to be 90 degrees. So just a sketch. It's going to be 90 degrees, and then this side will be the same as that side. So let's call it CD. CD is a perpendicular bisector. Okay, so a couple of things. So if there's a point here, that means that this segment is going to be the same as this segment, if it's a true perpendicular bisector. Same thing up here. If let's say we're down here, then this guy would be the same as that guy. Okay, and we know perpendicular bisectors are 90 degrees. So I'd say 90 degrees and bisect, cut in two equal parts. And then this piece is that if a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of the segment. Okay, so that's something we would use. Okay, and then the last one is angle bisector. So I'm going to leave that up because I know some of that was underneath. You might have to play catch up. Angle bisector. So again, I'll leave that up. I know that some of you might need that. So let's draw a couple angle bisectors, and we'll move on. And I feel like we've constructed these before. Let's draw some angles. So we got a nice acute angle, we got a right angle, obtuse angle, 3 examples. So if I was drawing an angle bisector, and we did this with the, we did this construction, we had an arc here, and then we had 2 arcs right here that would hit, and we drew a line through them, and I think we measured, and what we were looking for was for those two to be the same. Okay. So again, if we did that here, we get this kind of situation where this would equal that. Put 2 marks, just so you don't get confused with the other one. And then same thing here. Gonna get some kind of the marks being the same. So angle bisector is a ray that cuts the angle in half. Okay, so what you're going to quickly see is that, if this is x and this is 40, then x is 40. If this is 2x and say the whole thing here is 90, okay, then 2x would be 45, x would be 22.5. Same kind of thing here. Let's say we say, this is 30. What is, it's not going to work. Say this is 60. What is this whole thing? Well, if this is 60, then this guy's 60. We'll get 120. So that's where we're going. We're going, again, this chapter is heavy on the algebra, which is good for us because we need to keep working on that. Okay, and so it's just a disguised way of giving you more algebra, right? So we're just using these geometric terms, and really we're going to be doing some algebra. So that's really where we are. However, you do have to know the definition. So let's do a couple problems, and then we'll call it good. So just a quick model, and I'm just on this sheet here. Okay, so always label what you have. You got nice pictures here. Find x if GH and IH. So GH, the whole thing is x minus 3, and IH is x minus 7, and it says it's a median. So if this is a median, then this is the same as that. So if this is x minus 7, then this is x minus 7. And if I want to find the whole thing, I simply add the two middle pieces together. So I'll write the whole thing out. X minus 7 plus x minus 7 is x minus 3. I'm going to combine like terms. I have 2 x's minus 14 equals x minus 3. Golden rules of algebra, zeros and ones. 2x minus x is, and then subtract x is 11. Okay, so I'll give you a minute to get that guy in your notes, and then we'll play it forward from there. So that's median, cut it in half. And again, just another way to do algebra. I think like we've done these before, but I'll hit another one really quickly.